every time we do a survey, to be honest, our sample will never be exactly representative of the population. Remember, we talked about already in the first unit. Sample is the people that I do my surveys on, my examples, my people I go and question. Population is everybody that is affected. And to be honest, my sample will never ever be exactly the population. I will never get the exact results. You guys have seen it on elections, right? They're coming and saying, "Oh, candidate, this candidate seems like he's going to win elections. He's going to be your next president." Then elections come along and it's someone else. So our sample will never ever be representative of the population. As a rule, you have a rule that the larger the sample, well, the smaller the sampling error we're going to have. Now we're going to talk about errors that we do when we do our samples. The first one, we're going to talk about problems with the samples. Problems with the samples when our sample is not representative of the population. It's not really what my sample does not represent my population. As an example, let's say I come over and I want to see what people spend their money on. I go to places here in Bakersfield, California. I go and I start asking, what do you spend your money on? Food, your house, your card, and then I get responses. And based on those responses, I'm going to assume that people in Guatemala, notice I asked people in Bakersfield, and based on that, I'm going to assume that people in Guatemala do the same thing. Oh, here in Bakersfield, a lot of people spend their money in their houses. So in Guatemala, people must spend their money in their houses as well. Not quite, right? Different types of groups. So my sample is not representative of my population. Or let's not even look at different countries. Let's say I come over and I want to say, oh, elections are coming up. I'm gonna go ask Bakersfield people what they're going to vote on. And based on that, I'm gonna say, oh, all Californians are gonna vote on this because Bakersfield decided, they're gonna vote for certain things. So I'm gonna assume all Californians are going to vote the same thing, the same way. Not necessarily, right? Bakersfield people are not representative of all Californians. So that's our problem with samples. Sometimes our samples does not represent our population. Now we have another error that we call self-selected samples. Now these are responses only by people who choose to respond. You guys have gone to fast food restaurants, right? You guys get your receipt. At the bottom of most receipts, it usually says, "We want to know how your experience with us was. Give us a call," and then give us an 800 number. They even offered, if you call us, we'll give you free French fries next time you come over, or we'll give you a sandwich next time you come over. They even offer things for us to call. But honestly, how many times have you called? On every receipt of fast food restaurants, we get that. We want to know how was your experience, but we don't usually call. We called only if we're very strong on certain things. Why we have bad customer service that day we went. Oh, I'm gonna call and I'm gonna report it. I'm gonna let corporate know that it was a bad experience. But are all the experiences bad? Probably they only get complaints. But in reality, is everybody complaining? So self-selected samples, like I said, is people that choose to respond or not. And these are very, very unreliable. It's usually when you're so much in favor, like, oh, yes, I had an awesome experience at this fast food restaurant. I want corporate to know because it was amazing. Or, oh, it was horrible. This experience was really, really bad. But what about if you're in between? You just don't call. So self-selected samples it's not so good. Now, sample size issues is another problem that we have. Sample size issues, our sample is too small. I'm gonna let's say I want to study whether people like kernel learn or not, and I only ask two people. Right? We have a lot of students, and just two people. What if I got two students that really, really hate kernel learn? I'm gonna say, oh, I guess people hate kernel learn. All my students hate kernel learn because these two students that I asked didn't like it. Or what if I get the two students that really love Kern Learn? I'm like, oh, well, all my students love Kern Learn because these two students said so, right? Samples size issues is when the samples are too small, and that is very, very unreliable. Now, there's not exact number. I have to ask. Let's say I'm running the elections. I want to see what the who people will vote for in the next presidential elections. There's not a key number. Like I have to ask 100 people, or I have to ask 1,000 people, or 1,000,000 people. There's not a specific number, but we usually say the larger samples, the larger amount of people that I questioned, the better results I'm gonna get, right? Because the more people that I get, the closer it is to our population. I may get wrong answers. I may assume people will vote for a certain person and they end up voting for a second person. But people with the more that I get, I mean, the more and more people that I get, the more likely my answers will be. Now, undue influence. This is an interesting one. Undue influence when you're collecting data or asking questions in a way that influences the response. Okay, the way I ask a question, I'm gonna push you into answering what I want. Okay, for example, I'm gonna say, "Oh, do you like doing your homework because that's actually going to affect your grade?" Then, as a teacher, I ask you, "Do you like doing your homework because that is going to affect your grade? That is actually going to help you pass or not?" I'm already pushing you into saying, "Yes, yes, I like homework." So if I ask you, then I'm gonna say, "Oh, yeah, all my students love doing homework." I know many of you guys don't, right? Not that many people like doing homework, but because I said it in a certain way, the way I asked you, I'm pushing you into giving me the answer that I want. Do you like muffins that are really good for your health? Or do you like a rotten fruit? Muffins are really not that great for your health, but notice how I asked, do you like muffins that are really great for your health? Or will you prefer a rotten fruit? More likely you're gonna choose a muffin, right? You don't want to eat rotten fruit. So the way I asked you, the way I asked for my question, is how I'm gonna have you answer it. So be careful on surveys because sometimes they do that. Now, the non-response or refusal of subject to participate. Now, here the collected responses may be no longer representative of the population. Now, often people with strong or negative opinion may answer surveys, which can affect the results. Again, going back to the example of when you go to a fast food restaurant, if you had a really good experience or you had a really bad experience, this is this case. Non-response or refusal subject to participate. Not everybody participates. I mean, scroll up here. Now, causality. Oh, causality. Now, this is the cause. This is we're assuming that something. I give you guys a pill. Let's say I'm running some medicines, and I always tell you guys, well, if you guys take this pill, this is actually gonna take your headache away. And let's say I give you guys a pill that really, really does nothing. Let's say I give you guys a placebo. Placebo is a pill that does nothing. And they do exist. They do exist. They're just made out of sugar, kinda, or chemical that does nothing to your body. And then sometimes when we go to the doctor, then we're like, "Oh, doctor, I have this thing. You know, my head hurts. I have my throat hurts. My whatever hurts." And then the doctor sees us, and they're like, "Oh, because they're doctors, because they're doctors." We're like, "Oh yeah, they know what they're doing," and they give me a medicine. "Oh, go to the store and take this medicine." And then because the doctor gave it to me, then I'm like, "Oh, this medicine's gonna help me." I go over it and I get better. Now, sometimes I might have something. I might have a bad thing on my throat. I have something that's making me cough. I have something that's making me sneeze. I have a virus. So the doctor does give me something that does affect that. So that's why I get better. But sometimes it is just in my head. But because the doctor gave me something, I feel that this pill, again, it's nothing. It's just a placebo. But I feel that this doctor gave me something that is going to cure me, and then I get better. Now, the cause, what was given to me, the experiment that was the pill that I took, really did nothing to my cause. Right? A relationship between two variables does not mean that one causes the other one to occur. It's just that I got better. It was not really the medicine that I took. It's just that I got better. Now, our self-funded or self-interest study, this is a study performed by a person or organization, sometimes it's a group, in order to support their claim. So I want to come over and I want to push for people to vote for certain things. And then let's say there's Proposition A. I'm just going to call it A. They usually numbers. Proposition A. And I want you to vote for building more prisons. And then I'm gonna come in and then I want you to vote. Yes, I want to vote for. I want to build more prisons. Now I'm gonna come over and I'm gonna pay for all this because I'm gonna build a prison myself. If you didn't know, many prisons are there are private. They're not owned by the government. They're owned by someone. But I'm gonna come over and I'm gonna fund. I'm gonna pay for things because I want you to support my cause. Want you to build more prisons because I'm gonna get more money out of it. So now read the study carefully to evaluate the work. Every time you do a study, make sure you guys read it carefully. Do not automatically assume that the study is good, but do not automatically assume that the study is bad either. You gotta evaluate it, okay? So you gotta see who did the study. You guys are coming over and sometimes for election it says, oh, Proposition A is good. We recently had a proposition that was coming in saying that uh, uh, online gambling was going to be good, was going to be accepted, but I wanted people to vote against it. And then at the bottom it said funded by casinos. Yeah, of course, they don't want you to gamble online. They want you to go to the casino and gamble there, right? So studies were showing that people don't like online gambling. But who did that survey? Who gave you those answers? A casino. Why? Because they wanted you to not vote for that. Now, misleading use of data. Be very, very careful on this one. On the news, we see it a lot. Now, this is improperly displaying graphs or giving you a graph that is incomplete or it has lack of some like, context. As an example, I want to say, all right, how many people support candidate A, candidate B, candidate C, and let's say one of my candidates had 11 votes because I didn't survey that many people. So one of them has 11 votes, the other one has 15 votes, and then the third one has 12 votes. Now, if I do scales, if I do bars, you guys have seen bar graphs, right? And I go from 0 to 11 or from 0 to 12 and 0 to 15, you guys are going to see my candidates are very, very close. But I don't want you to see them very close. Instead, I'm going to write from 10 to 15th. Okay. Let's take a look at this. Let me show you guys here instead. Let's say again, I had 3 candidates. And then my candidate A had 11 votes. Candidate B had 15 votes. And candidate C had, let's call this 12 points. If I do a graph, here's 0. And let's say here's 10. And here's 20. So if I do from here, I'm going to say, well, candidate A goes up to 11, right? So it's a little more than 10. Candidate 15 is, candidate B is right in between 10 and 20. So it's about there. And then candidate C It's about there. So it looks like they're pretty close. But what if I don't show you the whole graph? I just show you guys this. And then I say, this is my bar. This is what I show you. Now you're going to say, well, candidate A didn't get that many votes because you're only seeing this part. Candidate C got a little more votes, but candidate B, on the other hand, ooh, has a lot more votes. So you got to be careful, right? I gave you data, I displayed you a graph, but instead of showing you the whole graph, I only show you part of it. Why? Because I want you to think that candidate A, not that many people like them. In reality, the votes are very close. 11 votes for the lowest and 15 for the highest. They're pretty close. But I'm showing you a graph where they're not really. So be careful with misleading use of data, right? I'm going to show you graphs, but I'm going to improperly display them. I'm going to show you the graph wrong. This happens a lot in commercials. I want to say, oh, my candidate, my president is really good for the economy. Let me erase this. Let's assume, I'll show you guys something. Let's say the economy, I have a president that is, the economy is going down. It's going down, it's going down. It goes up for a little bit, then it goes down and it goes down, it goes down, and the economy is going really bad. But then they come over and I only show you this. Oh, studies reveal that this candidate is awesome because the economy is going up. I can see that it was very low and then now it's very high. When in reality, if I look at the whole picture, yeah, this candidate is bad. So you got to be careful with that. Now, I mean, looking at our confounding, I guess I was not showing the pictures, right? What I meant on the pictures of my candidates A, B, and C, I had something like this. This was my candidate A, B, and C. But what I said, it looks very similar. But what if I just show you that? That's where it represents. And when I was talking about the president, the economy going down, goes up and then goes down. In reality, the economy is bad, but I only show you this. So be careful on that. Now, in the last one, confounding. Now, this is when the effects of multiple factors on the response cannot be separated. Right? What if I come and say, well, smokers and drinkers have been having cancer. So smoking and drinking does give you cancer. What if it was just smoking? What if it was just drinking? What if it's both? I combine them, and then yeah, if you drink and you smoke, you will get diseases, you will get sick. And in this case, I'm saying cancer. But the thing is that they're not separated. Confounding makes it difficult or impossible to draw valid conclusions about the effect of each factor. Smoking and drinking is bad. They give you cancer. Yeah, they're bad. You know, each of them are bad. So hopefully none of you are doing either one. But I'm saying smoking and drinking gives you cancer. Which one really gave you cancer? Did both give you cancer? Did neither of them give you cancer? Like, which one was it? Like, right? I cannot separate it. My data cannot be separated because I told you drinking and smoking. I combine them, but then we don't know exactly which one is it. So that's the problem with confounding. You guys have heard co-ed? This kind of sounds like co-founding. They're together. So that is another measurement error. Again, for your homework, what I'm going to be doing, I'm going to just give you guys some scenarios, and then you guys have to decide which one of all of these is it. Okay, so I'm just giving you guys scenarios, and you guys tell me which error is it.